Our speaker this evening is Steve LaFlamme. He's been a member of Skyscrapers for a few years now. And what is it? Amateur Astronomical Society of Southern New England?
Yes.
Have I got it right? He's been an amateur for quite a while, interested in astrophotography, and he's going to tell us about space junk. So welcome everybody, Steve LaFlamme.
I'll talk while you're working on that. Anyways, this topic came about a year ago plus 1 day, back on November 1st, 2023. A simple act when an astronaut up at the ISS was outside the space station, and the simple act of full bag having it drift away from the ISS led to this talk. And I don't know if you remember that in the news at all. It's not the first time it's happened, but I'm going to discuss some different areas of space junk today. Space junk could be described as anything man-made that's up in space. So it could be talking about the golf ball on the moon. It could talk about the parachutes we use to land on Mars. It could talk about all these satellites that are going around and around and all the debris that's spent rocket boosters that are up there. We have some probes that we sent to land on comets. Space junk, anything man-made that's out there in space and we have no way or no intention to ever retrieve. Can you hear me way in the back? Is that okay? Okay, good. During my talk, if anybody has a question, just raise your hand. I don't mind being interrupted. How does that show? Here we go. So Adventures with Space Junk. And as I said earlier, this all started on November 1st, 2023. And I'm going to start by showing you this news video about the tool bag being released by the astronaut. It's only 1.5 minutes long, and this is the news story as it is.
We've all misplaced a thing or two, but earlier this month, 2 NASA astronauts accidentally let go of a tool bag while making repairs to the International Space Station.
Do not see my bag.
Whoops. But don't worry, the bag is far from being lost. Days after it slipped away, a Japanese astronaut spotted it and snapped a picture as he passed over Mount Fuji. The bag is small but highly reflective, so it's pretty easy to track where it's headed. Plus, it's following the same path as the International Space Station.
We know it's following the same path as the International Space Station. We know that the tool bag is about 10 minutes ahead of it now, so it's traveling quite fast. So the idea would be to know where the space station's going to be.
And that's not hard to figure out. The European Space Agency has a live ISS tracking map. So space fans, keep your eyes peeled. Astronomers say you can spy the lost tool bag from some locations with just a good pair of binoculars. This isn't the first item lost in space. In 1965, NASA astronaut Ed White lost a spare glove while becoming the first American to go on a spacewalk. Another tool bag floated away from NASA astronauts in 2008, and in 2017, a piece of thermal shielding drifted off during repairs.
So here's that picture that the other astronaut took of the tool bag floating away. I mentioned this happened on November 1st. So for the next few days online, there were stories about this tool bag being in the same trajectory as the ISS orbiting the Earth, but it was about 10 minutes or so ahead of the space station. So there was somewhat of an accurate clue as to how to find it, but not foolproof. So by mid-November, there was a website nondescriptly called N2YO, is this the name of this website here? And if you look at the date there, November 18th, so this basically tells me from close to my location at home, November 18th, if at 5:23 p.m., if I look a certain number of degrees southeast, 131 degrees of azimuth, and I look up 68 degrees, that's where the tool bag is going to be passing through at 5:23 p.m. There's no mention here of how bright it's going to be, what it's going to look like, but I was eager enough to get out there and see if I could. From my backyard, no less. So this is a CCD image, actually a DSLR camera image of those coordinates that I told you. This is my backyard looking at azimuth 131, looking up 68 degrees, 5:23 p.m. I set the camera to take a repeated 30-second exposure. So every one after another, 30-second exposure starting around 5:20 or so, and to keep taking pictures. And sure enough, right at the 5:23 snapshot, this little streak of light goes right through the field of view. Close enough, you know, for government work, as they say. But right on cue. So what I did is, you can see this star down here. I kind of took this little area here and blew it up 300 times to see if there was anything more that I could see. I didn't expect it to be a relatively smooth line like that. I thought it might be tumbling and reflecting different parts of sunlight. The only reason we can even see this tool bag in the nighttime sky is because it's reflecting sunlight. You know, it's probably got white sides or like foil sides to it or something, and the sun is shining off it 100%, and it's reflecting back down to earth. So that's the only way we see this. It's not an illuminated bag on its own, but it's pretty amazing because it's only the size of, you know, a small suitcase or whatnot. One thing to note about the bag is that it had $100,000 worth of tools in it, and they had a second one on board. So all was not lost. So this thing went around the earth quite a few times, and I think 2-3 weeks later or so, it ended up burning up in our atmosphere. But it was fun it was a fun project to try to catch, and fun to see anyway, and fun for me. I like these unusual astronomy topics and try to like see an opportunity to catch something unusual. I'm all over it. But it triggered more, as you're going to see as my talk goes on. So some of you may be familiar with these Starlink satellites that go overhead. Every month or so, it seems that Elon Musk releases another swarm of these communication satellites. Usually 30, 40, 50, 60 of these at a time. He'll send up, release them, and they present themselves as a line of satellites. And the line is pretty close together the first or second or third night after their release. And over time, they separate, they get further apart. They go up higher in their orbit, and they become tougher and tougher to see. But I know that some of you have talked to you in the club before, have seen this go overhead. And the first time you see it, you say, what the heck is that? You know, you just see this string of beads going across the sky.
My nephew called me one night and said, I've seen aliens going over.
Yeah, especially if you're non-astronomy type.
Yeah.
You know, to see this is quite startling, and it's pretty cool to look for too. If you know that the key is to find them just within a couple of days after they're being released. So Starlink satellites. So consequently, I use this heavens above, heavens-above.com website is my go-to website for seeing what's up there that's going to pass overhead as far as space junk goes. From your home, you're going to want to put in your coordinates, you know, your latitude and longitude, so that it'll give you very specific maps and times for when things are going overhead. And then over here on the left-hand side, you can see if the ISS is going overhead. You can see the Starlink passes, you know, from a particular launch. So you can click on it, will give you the times and a little map of the night sky and show you where these things are going to pass through and what time. So as luck would have it, just a few days earlier in November, there was a release of some Starlink satellites. And from my backyard, starting over here in the west and heading this way towards the east, a string of Starlink satellites, 30 of them, was going to pass exactly through this area of the sky. So I happened to pick that star in Lacerta, the constellation Lacerta, because it was high up and visible from my backyard. And the time here was going to be 17 is 5 o'clock, 5:13 to 14. So roughly 5:13 and 30 seconds or so, it was going to pass near this star. So what I did to get ready for this passage of this satellite swarm was set my DSLR camera aimed it at that area of the sky, and I was taking repeated just 1 second exposures. So 1 second, 1 second, 1 second. It was just kept storing them on the SD card. And sure enough, to like clockwork, in 1 second, there's 5 different satellites going through this field of view here. You can tell by 1, 2, 3, and then there's 2 of them here kind of close together. You see that? A couple of things to note about these. One thing to note, the overlap area right there is shown right here, is that they seem to have a black line across the middle there. Can you see that way in the back row? There seems to be a black line in the middle, and they also seem to be blue in color. This is the camera, this is the color that the camera picked up, and they, to my eye, they look rather blue, and maybe they do to you as well. So from that split in the little twin blue lines there, I got on the internet to try to find a picture of what these Starlink satellites look like, to see how they could be sending, you know, 2 parallel streaks of light. This is what I found is what they look like. Their big solar panel mirrors must get unfurled, you know, to capture sunlight and give them electricity to work on. And I don't know if that black line has to do with this black line in the center of the panels. I don't know how accurate these, you know, depictions are of the satellites themselves. But I thought it was interesting that they showed the satellite panels as being blue, and that's the color that the camera was picking up at the same time. Now, this was last November that I took this. If we fast forward to August this year, this is right from the page of spaceweather.com. It's a astronomy website that I look at every day to see what's going on with the sun, see what's going on for rapidly happening space news. But this post for August said that Starlink satellites are turning blue. When they first started launching them 5 years ago, most astronomers saw them as red, but they're seeing them blue now. And they show up blue in these pictures here that someone else took. And they think it's related to the fact that astronomers, the amateurs, professionals are so irritated with how bright these things are in the sky that they're starting to use some kind of blue anti-reflective paint or surface on them to minimize how intrusive they are to photography in the night sky and whatnot. Which it says down there, it says that these are direct-to-cell satellites, and the material they're using to try to reduce the brightness gives them a blue color, which SpaceX says is not unexpected. The blue is visible to the naked eye. Yes, Steve?
What's their visible magnitude?
Of these, they were second magnitude, I'd say.
Oh,
Yeah, to the naked eye. You could see them naked eye, about as bright as the stars of the Big Dipper, I would say, in general. But each night they get further apart from each other and they get higher up and fainter, you know, so the next night they might be third magnitude and there's more of a gap between them and so on and so on. And eventually they tend to disappear. This is all I use to get these pictures. This is just a Canon camera with a standard zoom lens on there, and there's a dew heater at the end, and it's mounted on top of my telescope inside the observatory so it can track the sky and find the right locations. But the equipment itself is pretty simple. You know, it's just a camera on a fancy tripod, basically. So this led to, while I had this setup, taking these wide field pictures, there's a target. My camera is not modified, meaning it's not sensitive to red emission nebula. But before I took this camera off the telescope, I wanted to take advantage of the wide field of view and try to capture a picture of this. This is something it's always been a cool target. It's appropriate for this time of year because this is called the Witch Head Nebula. I don't know if you can see the witch's face in there.
yep.
You know, it's looking this way. She kind of looks like the Wizard of Oz witch there, the Wicked Witch of the West. So there's a target up, but it's kind of big. It's, you know, it's several degrees this way and a couple of degrees that way. And where this is located in the sky is just off Rigel, Orion's lower, what would it be, his lower left foot. And then the Witch Head Nebula is right here. You can see how big it is, right? It's important to note that the celestial equator, the 0 degree line of latitude on the celestial sphere, runs through the star Mintaka, pretty close to it. So what that means is the Earth's equator, which is 0 degrees latitude, projected outwards from the Earth and up into the celestial sphere, would pass right through that. There's 0 degrees. Anything below that is minus degrees or degrees south. Anything above would be plus or degrees north. So if you notice here, the Witch Head Nebula is about 6 to 8 degrees south of the equator. That's important and a kind of a lucky coincidence that that's the area of the sky that I was trying to image. So I set up the camera. I wasn't sure what kind of results I was going to get, but I put a lot of time into it because I know this is a faint target. And I set up to just take 1 minute exposures with the camera and to do that for 4 hours. So 240 total exposures. I wanted to have a lot of data building up with the clouds of this faint nebula to be able to work with and process and hopefully get my own good picture out of. So I set up the camera, I set the mount to track it. But before I get into the results of that picture, I want to share something that happened a year earlier. A year earlier, I was in that same area of the sky with a big, large CCD camera trying to capture the Witch Head Nebula, and it barely shows up at all. 1 exposure, 3 minutes, you barely see any signs of it over here. But what it did pick up was this 2 satellites, really slow moving. If this is 3 minutes exposure, it took 3 minutes for these satellites to go very short distances. And then the thing that really had me scratch my head was this one here. This satellite strike here that goes up here and takes a turn. I've never seen that happen before. Satellite. I just assumed that they all had to go in perfectly straight orbits, whether it's over our equator or over our north and south pole. I'd never seen such a thing like that. That's why I said, what the heck here? I posted this picture on Cloudy Nights forum, you know, to ask if any other amateurs or maybe even professionals would have some kind of opinion about this. And they all blamed it on my mount. They said I was using, they said I was using a cheap mount when I know the mount cost me almost $10,000. You know, it's an astrophysics GTO, you know, 1100, and it's not the mount. It's not a reflection from nearby stars or anything like that, because none of the other stars really reflected. There's no other lines like that. It's not really, it's kind of shaped kind of odd. Like it's not like it doesn't look like it would be a perfect circle. So I got all kinds of opinions, and then some people say, well, maybe there's stuff up there that is able to take turns in space and change its orbital path that we just don't know. You know, we're just common folk, right? But I thought it was interesting because this, from a year previous, was already something I had in my files that weird things happen in this part of the sky. So my result from that 4 hours of 1 minute exposures was this horrible picture right here. The best part of it is right here in the corner. Nice dark sky down there in the corner. You can see a little bit of the witch's face here in the middle. But other than that, it's all washed out. And there could be a number of reasons for that. Sky glow, low in the south. That's where my light pollution is, looking south. People's Christmas lights, you know, this was getting towards December now when I was fiddling around with this. It could have been low clouds going overhead. There's all kinds of reasons, but anyways, this was a failure, you know, and a failure project. And I'm used to that every now and then. You don't win them all in astrophotography, that's for darn sure. So I had this file on my computer of all these 1 minute exposures, and I looked through them quickly, and I was starting to delete them. And some of them caught my eye. Some of the short 1 minute exposures. For instance, here's one. The witch head is in there in the background, believe it or not. This is a short exposure. Airplane went flying right through the path. But one other thing that happened here. One other thing, if I zoom in and go up a little bit. See those little lines?
Yeah.
You can see them way in the back. So in 1 minute, I had these, you know, 3 little satellite streaks go through. And I didn't really think much of it. You know, it's not unexpected to see satellites passing through the field of view. But as I looked at more and more of these images, getting ready to dispose of them, here's one of the other ones. I know you can't see the lines up there, so I zoomed in on it on this next slide. It's this area where the satellites are, just zoomed in a little bit. And in this one, you can see
They cross it. Oh.
it looks like there's two of them crossing here and another one behind it. So like, okay, that's unusual. Trudging along through these images, and they're all about the same place on the picture too. If you look at where they are placed, they're all placed up here, like in the upper third of the image. They're all in this general similar area of the sky. So there's the crisscross. Then this one came up, and here's a close-up of this one. This one, there's 4 of them in a row, and then there's 3 right here. There's 1, 2, 3. They're all almost, you know, in the same line of sight. So altogether, there's 7 of them passing through this short 1-minute exposure. So like something's going on up there, you know, I don't know if it's a fleet of aliens or what's happening up there, but something strange is happening in that area of the sky.
Did you post those at all?
I think I did. I think I put them on some various groups, but this is the one that intrigued me most. This was towards the end of that 4-hour shift of taking pictures. And if I zoom in on this one, you can see 3 of them. All right, 3 of them there, and then this very strange one down here.
Oh, wow.
Get that centered.
Is it that it was blinking at just the right frequency to make that kind of pattern?
Strange, right? It seems to be blinking or tumbling or doing something in a strange pattern, because there's like 4 or 5 bright ones, and then there's 2 dim ones in between. You know, if you were up close like where I am, you see 4 or 5 rather bright dots, and then 2 faint ones, and then 4 bright ones, and then 2 faint ones. But as it went across the field of view, the successive or the next picture that I took is right here. And this is the close-up of this one.
Oh,
Huh,
See how it changed patterns?
yeah.
Now it's a bright one with 5 fainter blinks, if you will, and then a bright one again. So this is making its way across the sky, and just happened to show up on my picture. So there's one more before it goes out of the field of view. This one, and then the close-up. It's this one. I think this one showed it best.
alien Morse code.
Right? Very, very strange, just like a string of pearls, you know, going across the sky.
And the center one in each, yeah, is a little brighter than the others on each side of it.
The center one? Oh, that
No,
one?
no, you got the 5, the middle one of the 5 lighter one.
Oh, yeah, you're
Brighter.
right. You're right. The center one of the 5 in a row faint ones is brighter than the other 4. Yeah, that's a good point, Linda. So something strange is definitely going on here, right? Do you agree?
Yeah.
I know it was 5:30 a.m. and I was rubbing my eyes looking at this, but something definitely strange.
Somebody's CubeSat experiment. I remember we had someone from Brown talking about putting up a satellite with a blinking light. I don't know if that ever, I don't know if the ground.
I don't know. I don't know if this is part of that or what it is. So what happened next was, if you've seen my talks before, you know that I go to the astronomy lab. The astronomy labs is that I take these images and I look at them under the astronomer's microscope and try to figure out what's going on. So when I take something into the astronomy lab, it means I drag it into Photoshop and I try to do something, make it more visible, which you're going to see right here. So this is that last image that you saw, I think. I think this was the last one. What I did was this. What I did was take my image and I superimposed it on a planetarium program. So you see how the stars light up? I mean, they line up perfectly with the program behind it. If I decrease the opacity, you can see, you know, the stars are there, but the only thing that's new is the satellite going through. See that?
Mhm.
So by doing that, I was able to take some numbers and make some calculations and figure out exactly where this thing was at exactly the time that I took the picture. Figure out how far it moved and whatnot. I was able to get more information out of this, and I'll show you what I did with that. So from the astronomy lab, we looked at that. Here's that image again. So I was able to put some hard data behind these pictures and show where it was located in the sky. These are the celestial coordinates, where it was. Notice it's 6 degrees, almost 7 degrees south of that zero equator line that was below the earth. So it's near the vicinity of the witch's head. The camera that I used, it's a single 1 minute exposure, and I was able to carefully measure from one end to the other in a minute. And it measured about 14.9 arc minutes, which is half the width of a full moon, just to give you an idea. A full moon, when you look up at the moon, is about 30 arc minutes across. This distance is about 15. And then the faintest stars that we can see in this picture are about 15th magnitude. So I had something that I could post and show people and try to ask questions about what this was. I did some quick math. I got out my old calculator, my old Grossman's pencil. And what I did is I figured if this thing went 15 arc minutes in 1 minute, you know, then how far does it go over a longer period of time? So in an hour, it goes 900 arc minutes. In 24 hours, this thing goes 21,600 arc minutes. So I said, all right, how many degrees does it go in 24 hours time? And when I got my answer, it came out to exactly 360 degrees. So, which means that it goes around the globe exactly one time in 1 day. So this thing has a curious movement to it, right? It's very slow moving. It means if I come back tomorrow night and look in that same area of the sky, it should return there because it's gone a full circle in 24 hours, more or less. Up until this time, I hadn't been too knowledgeable about geosynchronous and geostationary satellites. So when I started to probe this on the internet, I found this really good article written in 2017 by Bob King from Sky and Telescope magazine. And he tells all about how you can actually photograph and see these geosynchronous satellites. And from this time of reading this article forward, I really learned a lot about this very particular type of satellite. And I'm going to explain that to you here. So the article says that from where we are, located around 40 to 42 degrees north latitude, that's where most of us live, you know, Rhode Island, Massachusetts, whatnot. We're right around 40 to 42 degrees north. He said that these satellites would be visible at a line roughly 6.5 degrees south of the celestial equator, you know, which is right where the witch head would be. You know, if Orion was up here, if this was closer to November, December, you'd see Orion up there, and then Rigel would be right in this general area, and that's the area where these satellites can be picked up. So I said, oh, that's interesting. I just happened to be luckily looking at that area of the sky. This map from 2011 shows that all these different geosynchronous satellites that are out in space, where they're located. And these things have to be located at 22,236 miles from Earth. And they have to be moving along at 7,000 miles an hour to hold their position over the same spot in Earth. And the reason that they're beneficial is that for any given night, if you look up in a particular spot in the sky, you know, not counting celestial coordinates or constellations or anything like that, the satellite would be up in the same spot night after night after night. The advantage of having that kind of satellite is communications. You know, if you to keep satellites steady in space and they're not moving around, they're easy to bounce signals off of and crisscross and whatnot. Sirius XM radio has one of these geosynchronous satellites up there. A lot of the cable networks and weather satellites, the GOES satellites for weather monitoring up there, and a lot of spy satellites as well. You know, I'm sure, you know, we have them directly over Moscow and they have one directly over Washington, DC, right? So these geosynchronous satellites are what I'm taking pictures of. So I went back the next night or so and started just to hunt back and forth in that band where I could expect to find these things. I have the motor drive on for the telescope. And sure enough, before long, I started to see these short streaks of satellites going by. I'm tracking on the stars again to keep the stars as pinpoint points of light to counteract the Earth's rotation. And sure enough, there's 3 more if I move the scope. As long as I stay in that belt, 6.5 degrees south, there's more and more of these geosynchronous satellites. The key is when I turn off the motor drive to the telescope so that it doesn't track the stars. So I just aim my telescope, turn all the motors off, and just let the telescope stare at one of these things. The stars continue to drift by in the background, but the satellite stays exactly put. And that's the cool thing about these, is that it's always there. So after a few nights of doing this, I developed some new friends out there, right? I know that one. I know there's 2 of them over the weather vane, and I know there's one above our neighbor's TV antenna. There's 3 above the chimney over there, and they're there all the time, night after night after night. I spent one night after this just going from my trees to the west, from my trees to the east, and just slowly moving the scope, at -6 degrees, of declination, and seeing what came out on the camera. And I was able to see about 40 of these, on any given night. There's about 40 of these in my little window that I have to detect these things.
What are you doing that they want to watch?
I don't know. But I pulled all my shades down. So you've seen these before. You may even have one of these on your house. And these are the satellite TV antenna. And the advantage of having a satellite that's permanently stationed is it doesn't have to follow anything. It doesn't have to track. It just corresponds. Once they set the angle and whatnot on this and they find the strongest signal, they just tighten it down and it stays permanently attached to receive your TV signals. There's 2 of them up there. These are like 1-minute exposures. Now this 2, I think we were looking at these in December. So what happened is I had a small camera looking through the telescope, a C11 at this point. We're looking through a bigger telescope, and the camera was pumping a signal into my house, into the basement. I sit at a desk in my basement, not outside in the cold. But I found these 2 satellites and put them in the center of the telescope field of view. I went outside, took the camera off the scope, and put an eyepiece in instead to see if I could see these 2 things visually. They were seen in the telescope. This is not a picture because I couldn't take a picture of what my eye was actually seeing, but 2 things happen. If you turn off the motor drive, then the stars drift by and these 2 points of light stay perfectly still in the eyepiece because they don't move, right? The Earth's moving and it makes it look like the stars are moving in the background. Or if you turn the motor drive on, the stars stop moving and then these things drift across the field of view. So they can't all be doing the same thing at once. So it depends how you want to visualize these things. They were about 12th magnitude. They were not real easy to see, but it was pretty neat to see them. It was neat to see them, I'd say, as standing still while all the stars are moving by them. It makes them stand right out that way. It makes them easier to see. After my friend Mike left, he's from another club I belong to, and he came over, we looked at this together. After he left, I tried an experiment. I decided what happens after an hour? Suppose I take an hour's worth of exposures of these things. Do they really stay in one spot for an hour? And I was surprised when I stacked these hour-long images together that no, they're moving vertically, right? They both moved either vertically or up or down. I wasn't quite sure at this point which way they're going, but they're certainly not staying perfectly still. So I said, that's interesting. So before I read that article that I posted that was in Sky and Telescope, Bob King mentioned that these things trace out the path of an analemma. I don't know if you're familiar with that term. This is someone's pictures, repeated pictures of where the sun is for different periods during the year. So in the summer, for the same location, so in the summertime, the sun runs way up high. And then in the wintertime, the sun is at its lowest. And then it kind of changes as our angle seems to change as we view the sun. And they get this figure 8 called an analemma. And that article said that all these geosynchronous satellites also exhibit an analemma. Not in the course of a year, but in the course of just one day. So I said, that's real interesting. So if I take pictures of these things for a day, which I could really only do half a day, right? Because we have daylight for half a day. I said, maybe I'll see some kind of pattern to what these things are doing. This is generally for a satellite that's directly on the equator, the celestial equator. It would make one of these figure 8s. And they call this satellite station keeping box. As long as this box or the satellite is somewhere in this box, then the signal will be strong on your satellite dishes on the roof of your house. You know, so that's its designated area. It can't wander from there. And in order to be geostationary, there's a difference between geostationary and geosynchronous. A geostationary satellite has to have thrusters a little bit to keep it perfectly in position with the equator. Because we have all these tugs from the moon, you know, and different gravitational pulls from the sun and some of the earth. So geosynchronous means it only has to be somewhere in that area, but geostationary uses thrusters to keep it perfectly positioned. So what was my result with getting the analemma? Back to the lab we go. I'll show you the next picture that came up here. Okay, so for this one, my 2 friends that I showed you earlier, these are the same 2 that we had visually observed. I set my camera to take a picture every hour on the hour from 6 p.m. to 5 a.m. So 6, 7, 8, 9, 10, and so on. Just take a snapshot each hour for 12 hours, basically. And the next morning when I looked at what I got, let's see here. No. This is the sequence of events that we got. So 6 o'clock, 7 o'clock, 8, 9, 10. This is the 10 o'clock picture. You see something strange going through the 10 o'clock picture. I'll get back to that. 10 o'clock, 11 o'clock, 12, 1, 2, 3, 4,
It's making the.
5. So let's run that all in a sequence. See how they go up and then they both in unison kind of go up. They reach their highest point at midnight, which I thought was interesting. That's the 12 o'clock one. And then they start heading back down. And then at the 10 o'clock, you see that interesting little string of beads, another one going almost perpendicular to them. So I tried to make sense out of this. And this is all 12 pictures shown together, all stacked up together. They're not making the same shape. They're a little bit different. They're certainly, in another 12 hours, they're certainly not going to go down, make a figure 8 and come back. There's just not enough time in a day. I don't think that could possibly happen, you know, during the daylight hours of 6 a.m. to 5 p.m. again. So to make the best out of what I could with that, get this. I can close this one out. So here's the 12 individual snapshots. I said, what do these look like in another 12 hours? And I kind of guessed and said, I bet they would just make, you know, reflect it over the plane and try to figure out what shapes they would come up with. One of them almost made a circle. This is theoretical. This is my own guessing. I didn't think they would make that figure 8. And then the other one makes kind of a different kind of shape to it. And the reason I don't think they make that bowling pin shape, that figure 8 shape, is probably because they're not directly on the 0 line You know, they're probably not geostationary, they're probably the geosynchronous ones that are allowed to wander a little bit. So they don't quite follow the rules of the other ones that the article said. That's my guess anyway, but that's what I think they do during the day.
Steve?
Yes,
The NLMA defined, the figure 8 is defined by the equation of time. But you're doing this in one 24-hour period
right.
as opposed to 365 days. So that could be an explanation for why you're seeing something completely
Everything that I
different.
read in his article, and in addition places online, it says it traces the NLMA every day. I know, because it takes the sun 365 days, you know, to make
When-
it shape.
When Dennis Kachico did his world's first NLMA, there was a tremendous article in Sky and Telescope about the whole geometry of NLMs. If you could look back on that, it might be interesting.
Okay, I'm curious to know why they came up with these shapes, but you're gonna see an even more complex version of that in a minute. I'll show you some. Go into that. So that one that I mentioned to you in that 10 o'clock image, you know, this one, this intruder here that went through in the 10 o'clock image. Again, I'm scratching my head. This thing looks like it's blinking on and off, right, as it goes. Very curious about that one. So I dragged it into the planetarium program again and did some, I knew exactly what my dimensions were of the field of view. And I was able to figure out that this is 4 arc minutes, 4.02 arc minutes long to the best that I could measure. And this is a 3-minute exposure. So this is moving really, really slow, very slow. How slow? I did my math again. So suffice it to say that 4 arc minutes in 3 minutes means that it would go all the way around the globe and return to the same spot in 11.19 days. Or 11 hours, 6 hours, 11 days, 6 hours, 33 minutes, 36 seconds, if as close as I can do the math. Which made me say, wow, how can there be a satellite that takes 11 days to go around the Earth? I know the moon takes 29 days, but this is a fake, artificial satellite. So that picture was taken on January 9th. So I figured, oh, I'll just come out on January 21st at 4:32 a.m. and take a picture of that same area of the sky, and hopefully this thing will be passing through the field of view again. So I was ready for it. I was ready to satisfy my curiosity and see if I could catch this thing coming back like it should. Instead, all I got was clouds. So I'll never know. But I thought that was very unique.
I think Chandra's on an orbit like that, isn't it?
It's what?
Chandra?
Does it? Chandra goes that way, north, south?
Yeah, well, it's on a many day orbit like that.
Oh, is it?
Yeah.
Okay. Here's another instance where I took a picture of 3 satellites, and then there's 2 other ones kind of moving vertically, you know, over the course of 1 minute or whatever it was. Just strange behavior to these things. Earlier on, when I was looking through the subframes for that witch head nebula, remember I showed you the one that had 7 satellites in one picture? Here's the 4 over here that were kind of going like that, and then here's the 3 that almost made one thin line in a row. They're in the same spot every night. They're out there now. They're up there, you know, any night of the year. Put the telescope in the same place and they'll be there. So I did a little animation. I kept taking pictures of these things to see what they do over the course of just 1 hour. I have to warn you, some people get a little dizzy watching this next slide. So if it makes you a little dizzy, just look away. You're gonna see the stars whizzing by and the satellites staying put. But this is just an hour time and what these things do.
That's cool.
See that? There's another satellite going vertically again during that time. The only one that really shows movement is this one here. That looks like it's moving the most out of all of them. But they're really not moving. They're moving the exact same rate that the Earth is spinning, and it's the stars behind it that seem to be moving by. Here's what they drew out over 12 hours. I did the same thing, same setup as before, you know, and just let the camera take a picture every hour from, I think it was, I again, 6 o'clock to 5 a.m., 6 p.m. to 5 a.m., and then just trace their patterns. And you can see, we were talking about Anna Lemon, Steve, that there's like, how do you make heads or tails out of the patterns that these things are drawing, you know? These seem to be either coming towards us or going away from us, you know, and that's skewed somehow. Just, they're all going their own little which way. Which was interesting to see. This brings me to my final topic of space junk. Maybe I've shared this with you here before. Have I told you that I talked about seeing the James Webb
Yep.
Space Telescope? So Christmas morning, 2021, I know you all got up at 6 a.m. and put NASA TV on to watch the launch of the James Webb Space Telescope. Some of you did.
Sure did.
I certainly did, yes, because it was such a thrill to see this $10 billion project finally lift off and get sent off into outer space. So the show itself was probably only an hour long from the launch to this final scene. They showed this as, you know, Earth, the JWST had been released and it was being sent off to its L2 point, 1 million miles away. It's going to take 6 months to get there. And the commentator said, this is the last time humanity is going to see the James Webb Space Telescope. And it went by live on live TV, sent this thing packing. And that's the last that we're going to see of it, right?
Nope.
There's a website called The Sky Live. And they have one of their drop-down menus is probes, and when you go down there, you can see James Webb Space Telescope. And from the time that you hit that, you know, click on that link there, it puts up the coordinates for right now, for the time that you hit submit. And it shows you where in the sky that you can look for the James Webb Space Telescope. Now, this does move a lot around among the stars. You know, this isn't staying put like the other satellites. So you punch in the coordinates and you aim your telescope and your camera. The reason that you can, this is not my picture of this, is not what I got. I just want to point out that it has a very reflective side to it. It's 1 million miles away from us, and it has these very reflective, anti-heat, anti-light, reflective panels that keep the instruments cool on the other side. The total length of this is about the size of a tennis court, 70 feet, I think it is. And again, if we're able to see this thing still at 1 million miles away, it's because the sun is shining off the reflective panels. So here's what I got on this. Looking at those coordinates, oops, go this way. Taking 3-minute exposures for a little bit more than an hour. I think there's 12 different shots here. But you can, starting from the left side, you can see these little dashes with a little break in between. So the camera was allowed to open the eye for 3 minutes. The James Webb Space Telescope went across, made a little dash or a little segment, and then the camera closes for a short period of time to download the information, download the frame, which comes out of my observatory and into my basement and up on my computer screen. And then it takes another one, and you can see them progressing on the computer inside. And at one point, it gets really bright over here. See that? Either it's angled to the sun, improved somewhat, or maybe it was making a directional change or something, or looking at a different target, but it temporarily got bright for a minute. But sure enough, it was still visible. Here's a longer project, same idea. This time, instead of just for 1 hour, I did it for 3 hours. And at first, I was really frustrated because I could not find this thing at all. It wasn't showing up where it should. And I'll show you why in a minute. So these little dotted lines actually start way over here, you know, and I could not see it, could not see it, could not see it. And then all of a sudden, boom, see how it gets really bright all of a sudden? It went from being in the shadows or oriented improperly or something, and then it turned just right to give me a nice full glint of sunlight there, and then it started to fade a little bit more, and then it disappeared, you know, and then it came back into view and continued across the sky. So I think there's 60 different dashes here. So if I start, you know, counting 1 to whatever, I can almost count and figure out where it disappears over there, or when I started way over to the left there. But it was pretty neat to see, you know, either this thing's looking at different targets or it's just, you know, the sun is shining the right way so that we can see it sometimes and not see it other times. We're getting near the end here. This is the Webb telescope going across the sky when another satellite, there's a near miss incident here. See that? One of the frames caught a satellite going squiggly past. One of these is probably 200 miles away from us, that one, and then the other one's 1,000,000 miles in the background. Just happened to be in the same little stretch of sky. So keep looking up when you're out there because over time, these things like to come crashing down. Let me get a view here. These are all pieces of debris that have fallen from who knows what up there. This washed up on shore.
Oh, gosh.
Looks like the nose cone of a rocket of some sort.
Well, that could ruin your whole day.
Right? That would hurt, right? If we get that on you. A lot more space junk up there. It would ruin your day. That was in your living room. So there we go. This stops at 2013 and it's only increased exponentially since then, the last 11 years, just to give you an idea of how much junk there is out there. I just have one short fun thing to share with you. You all heard about the comet that went overhead recently. This comet Suchinshan. I took a ton of pictures of it. And one of them, I went out to a golf course locally to me and I had a camera on a tripod and used this computer here to snap pictures. And one of the pictures I ran out to get in the picture with the comet with a little dim flashlight shining so that it would light up the back of my coat there and get in the same picture as the comet itself. I didn't notice this until earlier tonight, but we've talked about that T Corona Borealis supernova that's supposed to happen any minute now. And it would have been really coincidental because this is Corona Borealis right here, the constellation Corona Borealis, and it's supposed to explode like right there. Can you imagine if that supernova went off and it was visible through the comet's tail at the same time? The
Back
week
to
after we
life.
had this Aurora Borealis and the total solar eclipse in April, like it's just too much to comprehend. So 2 nights, this is one of the nights that, you know, that the comet was visible that middle week of October. And for one final project before I wrap up, I decided to recreate an event that happened 65 million years ago.
Oh,
So this is pretty much in a nutshell what happened. So that concludes my little presentation.
Thank you, Steve. Appreciate it.
You're welcome.